Okay, let's get started. I'm Jessica Kerr. I am a principal developer advocate at Honeycomb, and I'm excited to be joined today by Matthew Skelton. Matthew, do you want to introduce yourself?
Hi, yeah, thanks, Jessica. My name is Matthew Skelton. I'm the co-author of this book here, Team Topologies. This was published just over 2 years ago by IT Revolution Press, the home of books like Accelerate and Project to Product and so on. And actually just yesterday, they published the new version of the DevOps Handbook. It's great to be here and looking forward to the chat.
Sweet. Okay, so we're here to talk about sociotechnical systems and observability. And I think you have some thoughts about why that's particularly relevant now.
Yeah, I was thinking about this recently because we've been doing a lot of work through my consultancy company, Conflux. We've been doing a lot of work with organizations that need some help thinking through reliability, the reliability of their software systems. And so we've been doing a lot of work trying to explain why this focus on reliability is so important. And part of the reason is this. If you think about the kind of software that was built like 15, 20 years ago, there's a very different set of assumptions that you could have compared to today. So on this slide here, what we can see kind of yesterday's view, we're basically writing software for a single machine or maybe a group of machines.
Oh, and we like knew which machines too. We can give them names, we can point to them sometimes.
Exactly, literally you can point to the machine is sat right there. And so we can kind of manage that in our heads. We expected to be able to specify everything up front because fundamentally the kind of systems we're building, generally speaking, were relatively straightforward. I mean, I remember back in, anyway, so they're relatively straightforward. So we specify things up front. The behaviors of those systems, therefore, were sort of predictable. Now,
we expected to be able to predict them because we could one human could design the connection.
One human could design it, exactly. So I've got 30 machines in my kind of big application at the time. I can sort of predict roughly what's going to happen. And organizations at the time had a kind of mindset around, well, let's get this machine working. Let's get our organization efficient like a machine.
Mm. And because it was at most complicated, you could focus.
Yeah, from a Cynefin point of view, exactly. It was like people just assumed that it's just something a bit complicated, and therefore if we manage it better and optimize it better, it'll just work. But we're realizing today, for lots of reasons, not just because the technology is more complicated, but that's part of it, that the landscape is actually very different. We've got distributed computing. That in itself has lots of challenges. We end up needing to detect what is needed. In other words, detect what our customers need.
Instead, as opposed to predict what is needed.
Instead of predicting, well, instead of specifying up front, well, we think we're going to need this. Well, let's actually go and work out what we need. Let's put something into production and see how our customers use it. And see if it works, because we might not know how this thing is going to work in advance based on all sorts of things, volume, different unexpected behaviors of external systems and so on.
I'm not so sure we knew before. We just pretended we did.
Well, indeed, we just pretended.
We filled out those requisition forms for servers.
And it's quite clear that the behavior of these systems that we're building and of the kind of groups of people involved is not predictable. We get emergent behavior. So we're often working with complex systems from a Cynefin perspective. So we have to adopt a very different way of working. We have to expect behavior to emerge out of the ensemble of things that are happening. And so our mindset is effectively an ecosystem. Things are kind of living and adapting and changing based on what they see inside this kind of ecosystem. It can be a business ecosystem, it can be a social ecosystem inside the organization, but it's definitely not a machine.
So we can't just get better at predicting the way we were before. We have to do something qualitatively different.
Exactly. If we think about just take the technology angles, you flick to the next slide. The technology angle in itself is enough for us to need this reliability and observability focus.
Just the quantity of servers, for instance.
So yeah, even just based on the quantity of servers. So I've tried to find some photographs here which accurately reflect the different decades. So in the 1990s, when I started writing software, I was writing software for desktop machines. The software was sitting on a single machine, and maybe it talked to a few other machines inside the office. So roughly speaking, there's like one machine back then that
you
the
could
software
hit
ran
it.
on. You could hit it, you knew where it was, you could pull the plug out, all that stuff. And then in the 2000s, this was like the birth of web, and maybe you needed like around about 10 machines to run an interesting size kind of website. I remember back in like the mid 2000s, we had half the population of the Gulf state of Qatar jumping onto our mobile phone website to pre-order mobile phone numbers.
Oh
because
my.
apparently in certain parts of the Middle East, like they really want a particular, I think it's 7, which is a magic number or kind of a lucky number. So if you could get 7777 as your mobile phone number, then it was very valuable. Anyway, we had literally half the population of this entire country jumping onto this website at one particular point when the auction went live. But we were running the website on 4 machines. The entire website was just 4 servers, and they were running quite hot, but it was fine. And then, of course, mobile came along, 2010s. So we need some APIs. And you've got all the mobile devices, explosion of devices at that point, basically. You've got a whole lot of web APIs to needing to serve that stuff, increase of different kind of content CDNs, content delivery networks, and so on. So maybe you need like a group of about 100 machines to run something on nodes.
Well, and then on the front end, you don't have this desktop anymore that you can control. It's everyone's devices that you've never heard of even.
Exactly. So there's a lot more variety. Yes, a good point. There's a lot more variety of possible ways in which our software might now behave. And we need to start being able to detect that.
Yeah, but you can't predict everything it'll run on, because in order to predict it, you'd have to restrict it.
Yep, exactly. But we're opening up to kind of multiple devices. We want that. We want to be able to reach multiple different devices. So we have to be able to kind of deal with that variety.
Mm-hmm.
And now, 2020s, we're talking in terms of nodes. It's not necessarily a server sitting in the corner, but the number of nodes in terms of containers. And these compute nodes are kind of often ephemeral. They spin up, and then they're gone in half an hour or 5 minutes or even a few seconds if you're talking about serverless under the hood. Then if you have, and so maybe there's like 1,000 or roughly 1,000 compute nodes involved in a sensible size software system. So over the last few decades, basically the number of kind of compute nodes has sort of gone up exponentially, increasing by about 10. Rough. I mean, this is a guess, but this is roughly what it feels like to me based on my experience and the experience of other people I know.
Right. So this line here is graphing orders of magnitude.
There's order of magnitude. If you were to draw it in a linear way, then you'd see like the hockey stick thing at the top right of the slide. Mm-hmm. And if you have if there is a kind of failure, a failure mode, or an unusual behavior, which is like 1 in 1,000. If you only have a single machine,
1 in 1,000 used to be rare.
It used to be rare, exactly. So back in the 1990s, 1 in 1,000. Like if you only got a single machine, you'll only see that error once every 3 years. But now, 1 in 1,000, you'll see it every day. And so fundamentally, the way in which you need to approach the kind of modern software system is radically different from the way in which you needed to approach it back in a few decades ago. The tricky thing is that a lot of the techniques that companies are using, both in software development and in product management and in IT operations, a lot of these techniques were grown and evolved in the 1990s, when we had the assumption of very relatively straightforward software. And a lot of these techniques haven't really fully adapted to this new world of emergent behavior in software and human systems. And so that's why we need this focus on kind of reliability, observability in particular, this expectation that we actually need to sense what is happening and respond to that, rather than prescribe something up front and just go and do it. And it's a radically different mindset, really.
Yeah, it's a change of expectations of ourselves instead of predicting everything that can happen and responding to the rest by hand. we need to make it smoother for surprises and be able to see those.
And the way I see
Yeah,
it is
here's the
exactly
cricket.
like this. The cricket's got this huge antenna that to help it sense its world, help to kind of get a sense, literally, of what's happening in the world.
Because the world is bigger. The world is bigger than like a little box that we build.
Yeah, and there's more happening, and it's dynamic. There's new stuff happening all the time. It's not just the world is static. And compared to today, the world of the 1990s in terms of computing was relatively static. New machines came along every few months. Now new machines come along every few seconds. It's a massively different kind of approach. So we need to be expecting to sense our environment, business environment, internal environment, all kind of different environments. And we need to find ways to do that through technology and through people, and the combination of technology and people, sometimes called sociotechnical. And to see this is a really key aspect of how we think about our organizational capabilities.
It is. And you talked about both on the social and technical side, and we need to both be able to cross those boundaries and knit them together. Right, so the title of the webinar is about how observability can help with this. And I put together a couple examples. One is the value stream. Team Topologies talks about stream-aligned teams and the value stream from customer through various bits of software to the encapsulated business knowledge that the customer is getting value from. So you can ask, where does the value stream flow? What teams are providing value to, I don't know, pick a customer request. Customer has sent a chat message, or in this maybe created an account. You can follow the different technology side services that it goes through. And then as a person, you can ask, okay, which teams maintain each of these? Are they talking to each other? If your software is talking, the people had better have a connection too, so that they can share information. So you can follow this value stream down. This also works asynchronously. Like if your services are doing HTTP posts and waiting for a response, you can probably say where they're going. But if your services are publishing on a Kafka topic, who picks it up? You can trace that too. And then you get this like skinny line out here that says, well, the welcome API said it was done, but actually all this stuff happened as a child span as a result of this topic that was published. There's other ways you can do this. You can also link them together. But I think if you have like event sourcing or any sort of microservice, put it in the river and let people pick it up, pick the events up kind of architecture, tracing is even more valuable. But then you can also go the other way. So if you work on the internal service team, you could be like, how do we provide value to the customer? Who all calls into us? Who's going to be affected when we change this, when we make this input field required, for instance? And you can go backwards. You can find your orange events and look at the traces that they're part of and see that, yeah, you knew about the welcome API. Did you know the welcome API was called asynchronously by this batch jobber here? Oh, that's news. And oh, hey, the mobile backend calls us directly. I didn't know that either. So you can trace the value stream both directions. Oh, right.
And this is incredibly important because when we're thinking about organizing our teams and technologies, architecture for fast flow, which increasingly many organizations are doing. So literally the subtitle of the Team Topologies book is Organizing Business and Technology Teams for Fast Flow. That's what
and by flow, we mean like changes to the software?
Exactly, yeah, we mean flow of changes to our software systems because there's a need for an ongoing flow of change. But the changes in regulations, changes in trade relationships,
in the threat landscape for security.
Threat landscape for security, exactly. Changes in technology based on what users are using, and so on and so on. But in particular, yeah, I mean, the zero-day vulnerabilities, we need to get something out there really, really quickly. And so we need to optimize our teams and the architecture for a fast flow of change. And one of the really key things we need to do is find good boundaries, find sensible boundaries that where teams can own a chunk of the kind of application landscape, software landscape.
Like a chunk of the value stream?
Well, a chunk of value stream, or it's something which maps through to a natural flow of change in the organization. We typically use techniques like domain-driven design to help us think about this, but there are other techniques as well. Some derive from things like Wardy mapping, where we can think about the user needs and work backwards from user needs, and then work out, well, how would our software architecture change in order for a team to be able to just focus on meeting that specific set of user needs, and a bunch of other techniques. And this technique here, when we're looking at spans, can actually help us do that, because if we're looking at the relationship between these different spans within a trace, we can say, is that a sensible boundary? What would happen if we moved some of the responsibility that's currently in this team over here into this other team? Because then the second team could maybe own better that kind of end-to-end flow of change inside that particular area. So for me, it's the observability that these, particularly the Honeycomb tool, but similar tools as well that provide teams. This kind of insight and awareness can lead to really good conversations about boundaries for fast flow.
Oh yeah, and when you're doing when you're customizing your instrumentation, I mean, in this picture, I've got like service name shown on the trace, but you could inject team name who supports this code, and then color by that,
yep.
in Honeycomb at least, and then you can see the flow between teams. And for instance, if down here you had something that was the same team as the top, you'd be like, wow, why are we going in a circle there through these other teams? Yeah.
Exactly. It's a really, really, really useful prompt for conversations between teams. And one of the things that we really talk about and try to emphasize in Team Topologies is the need to be thinking about boundaries all the time, because the technology changes, the landscape changes, the business requirements change. We need to be always thinking, have we still got the good boundaries for fast flow? Just because we defined them 6 months ago or 12 months ago, are those boundaries actually still enabling a fast flow of change, or has something moved on? Do we need to renegotiate effectively those boundaries that this team is responsible for? Almost certainly that's going to happen on an ongoing basis, and tools like this with this degree of observability is really going to help us have that conversation, inform that conversation with real data.
Have the conversation. Yeah, that's super important. And you talk about other types of teams too, besides the value streams.
Yeah, so I'll start to put a streamlined team shown in yellow here. And really, we want to make sure that most of the teams in the organization are that type of team. There's end-to-end responsibility, so they build it and they run it. You build it, you run it. So they're on call typically for the runtime software. And we've done work to decouple the application architecture as well as the social architecture. So the teams and the software systems are decoupled in very similar ways.
So that they can change at different rates.
So they can change at different rates.
Because otherwise everybody's going as slow as the slowest one.
Exactly. And because we put the effort into decoupling at the level of the business concept, so not even technology, but even outside of technology, from the perspective of the kind of business stakeholders, and certainly from a product level, we've done that level of decoupling so that these things truly are independent or substantially independent and don't have multiple cross dependencies. So that's our starting point, and that's what gives us this ability to have the multiple rapid flows of change. The diagram is shown with a flow of change going left to right. So that's why this diagram looks like this. The teams are kind of long and thin because they've got end-to-end responsibility, that they're not handing off to another team.
Okay. Oh, Simon just asked in the Q&A for an example of a streamlined team. So streamlined team might be like the login team.
So if you have, let's say it's a pizza ordering service, a typical streamlined team might be something to do with the different choice of pizzas and maintaining the pizza catalog. Another team might be responsible for kind of basket and checkout process. Another team might be responsible for kind of my past orders. These three things, the kind of catalog, the ordering process, and my account, are typically kind of logically separate things from a business perspective. And so we can easily kind of keep those things substantially separate. And therefore, teams can own one kind of slice of that of that process. So in that case, you'd have, say, three different teams. Obviously, it gets a bit more complicated when you're in a domain that's a bit more involved than ordering pizzas, but that's the principle. Where we've got some degree of independence from a logical business perspective between these things.
Do you see streamlined teams like, I should put a Wordly map in here. So the customer wants to order a pizza and you've got the ordering team, and they require the capability of communicating to the kitchen, and maybe another team supplies that?
Exactly. So
in a trace, you'd see that as maybe this orange team is talk to the kitchen.
Could be.
And the purple team is order the pizza.
And because we've done the work into being very clear about the kind of domain ownership and kind of boundaries like that, if we do then find in our trace something that looks strange because, oh, it's heading back into our domain, then back out again, that's again a prompt for a conversation. It is like a diagnostic tool that really helps us to zoom in on something that looks strange, because we've got a kind of a language and a set of principles to think through kind of responsibilities and architecture and flow. And so when we see something like that, immediately we might say, something's wrong there, if you like. I mean, it might be working okay in terms of the customer's outcome. They've ordered their pizza, but it's indicating that something's not quite right in terms of the architecture and responsibilities internally. And so it's probably slowing things down.
Right. David remarks that he assumes we wouldn't want to alter the boundaries too frequently, as this would impact the team cohesiveness. You talked about negotiating all the time.
So if we head just back to that the Team Topologies slide, what this slide is showing is we've got two streamlined teams. Let's say it's the catalog and the order process or whatever from the pizza shop. But what's happening right now in this diagram is the streamlined team at the top is currently collaborating with what's called a complicated subsystem team, shown in orange. And in this diagram, the kind of cross-hatching is a collaboration. Now, for us, collaboration is a very, very specific thing. It means working together very closely for a defined period of time to achieve a specific outcome. And usually that period of time is like days or weeks. It's certainly not months. And so in this case, maybe that the pizza catalog team at the top is working closely with this complicated subsystem team. Maybe that's like maybe they own a kind of search index or something like that, and they're trying to work out how to make it easier for the streamlined team to work with that search index, something like this. Maybe improve the API or some tooling around it. But it's not a permanent relationship. That collaboration will go away at some point because it's too kind of costly.
Okay, so you're using collaboration very specifically.
Very, very specifically. For a really specific intent.
All right. So sometimes altering the boundaries temporarily means introducing a deliberate collaboration.
Exactly. And that's a really important word, deliberate. We're being very deliberate. We're being very focused and conscious about the kind of interactions that we're having with other teams.
Because
and using that to inform the kind of design of the whole system and the design of our organization.
Because it's expensive, that level of close coordination and collaboration.
Exactly. And it's if we're having to do that kind of collaboration all the time, then we've kind of got a blurred boundary of responsibility. It implies that we haven't, exactly, it's not decoupled. We haven't maybe done enough work around understanding the business domain well enough so that we can actually pull those apart. But the collaboration is really valuable if we deliberately want to find a kind of a new interaction point between those two. So if we're working on a new API or a new way of using that tool or library or API or whatever, something like this, then it's super valuable to do that collaboration.
Nice. One of my favorite things about Team Topologies is how it points out collaboration is not the goal. Collaboration is a cost. Yeah. And sometimes has great value, and other times is just keeping us in the muck.
Yep. You can see in the diagram The complicated subsystem team is there providing a service to the streamlined team in the middle. Maybe that streamlined team in the middle is a checkout thing. And so from the perspective of checkout team right now, the streamlined team in yellow in the middle, or it doesn't have to work really closely with the complicated subsystem team. It's now just consuming it as a service. We've defined a boundary, it works for that team, and it's friction free. If it's working well, then it should feel really straightforward to kind of interact with that team. Is that the complicated subsystem team just is providing some kind of library or component or API.
So the goal is usually to move from this tight collaboration to this linky service as a service kind of boundary.
As a service, we call it X as a service. And exactly, it's the goal in the sense that the X as a service relationship scales much better than collaboration.
Yeah, so you can still change the interface, but there's a process for that.
Exactly, and if over time, so we might start off with this. So we've done some collaboration, then we move to this X as a service, and it feels, for the first 6 months, it feels great. This API is really, really working well. Over time, maybe we need to move back to collaboration because we need to kind of explore again what that interface looks like. We need some new features, or we need to improve something about it.
Or people don't care about searching for what kind of sausage anymore, and they're really into cheese now.
Yeah, or something more complicated, but yeah, something like that, exactly. Yeah. And so, but we're being conscious about, hey, we need a period of collaboration over the next 2 or 3 weeks just to work on this little aspect of this API like this. Instead of searching for a single type of pizza, we now want to search for multiple types.
Deliberate kind of periods of collaboration, as opposed to all the collaboration all the time.
Exactly. And likewise with, yeah, exactly. It's going to come to this. The enabling team is a different type of team of experts who help to bridge capability gaps in streamlined teams, or to help them upskill, and also to detect where there are multiple capability gaps across lots of streamlined teams, and then to do something with that. To be able to then say to someone, hey, look, we need to train all these people up in machine learning, or we need to train these people up in whatever, something else.
Because the challenge of a streamlined team, that end-to-end responsibility, is how many things you have to know.
Exactly.
You have to understand the runtime and production, and how you know when it's failing, and how to diagnose that, and how to develop, and all your frameworks and all your databases. So the enabling team can like swoop in and help you with some of that knowledge, right?
Exactly. And again, but again, the enabling team would be there for maybe days or weeks, not for many months, and certainly not years. Because if we've realized that actually 7 out of our 8 or 9 streamlined teams all have the same kind of problem, let's do something more fundamental to fix it. Let's not just try and fix it in a single streamlined team, but let's provide something. Let's, I don't know, send everyone on training, or hire more people with machine learning skills, or, so we'll come to this in a second, or actually maybe there's a need to provide something from what's called a platform at the bottom in blue. Provide something like machine learning as a service. Provide that capability from the platform to make it easy for all of these streamlined teams to consume or configure the machine learning system, for example.
Right. To reduce the amount of knowledge that you need in order to use this capability.
Exactly. Enabling teams, crucially, should be explicitly sensing where these gaps are, where these opportunities are for improving flow in multiple streamlined teams. So it's an example of how we can start to have this kind of organizational sensing. Remember the insect we saw before with the antenna. They should be doing that. They should be seeing themselves as kind of antenna for capabilities and challenges inside the organization that's building and running the software.
So they're not just providing knowledge about whatever technology they specify in, they're sensing as they move around to collaborate with different teams, they're getting a wider picture of what's happening in this social organization.
So one specific example would be enabling team. You might have a group of people who really understand spans and traces from a system like Honeycomb, and they go in and work with multiple streamlined teams, one after the other, and say, look, let's look at your current traces.
Oh yeah.
What is this? What exactly that diagram? So what is this telling you? And help them to think through what this means in their team context.
Yeah,
Would
yeah.
it,
And when you get to like this big long span with nothing underneath it, you're like, okay, let's break that down. Let's
yep,
add something underneath that.
exactly. And
Whoops.
they would help those teams to do that, help them to become aware of how to use that technology and how to use that insight to help them, go quickly, have a fast flow of change, but also kind of look after the viability of their boundaries, of their software boundaries,
And the
to have the right
cognitive
kind of
load.
conversations.
Because
Yeah,
if you can put enough information in your traces, that really helps with reading code. It helps with bringing new people onto the team and understanding what's happening in your system.
yep,
Enabling teams can also use traces to show the streamline teams what's going on. Like if you had a DBA team that could show you a trace that looks like this and is like, I think maybe your ORM is not helping you here.
does the ORM ever help? Sorry.
Oh yeah, totally. Like in spin up, it's totally great for toy projects.
Yeah.
Anyway,
No, but it's a
opinions.
really good point. It's a really, really good point. So specialists on an enabling team would look at this and immediately it would tell them something straight away. But someone, let's say, a more junior developer or someone who's coming in from a different set of experience might not know how to interpret something like this. So that's where an enabling team can come in and go, look, if you look at a span like this, what this is telling you is X, Y, Z. So, somebody's going backwards and forwards in the request here. It shouldn't need to make that number of requests. Let's try and, I don't know, update the ORM or ditch the ORM entirely, whatever. And so they're
Right, or at least
uplifting
use
the
it differently
skills.
in this case. Yeah.
Oh, just use it differently. But they're uplifting
Yeah.
the skills in that streamlined team. That's so important.
Yeah, and when you make that change, when you can see the difference in the trace, it's really great because sometimes it's like, well, I can make that change, but how will I show a demo to the product owner? This is one way to show the product owner that the software is doing something different now. If you can make this trace look a lot shorter and simpler and make more reasonable. Platform teams too can use tracing. Like in this case here, we have a continuous integration build and the team is like, my builds take forever. Your platform needs to go faster. And the platform team can show this is what is happening in your build. This is how you are using the platform. And you can see which tests are causing the build to be slow, because if your tests take longer than the NPM install, they probably take too long. And when there's a failure, maybe there's like a recurring failure, you can see that the tests are definitely running in parallel, useful for concurrency, and you can find it. And then Ian has a great question in the Q&A right now about, with millions of traces, how do you see what's going on? This is only a partial answer to that, but if you have a recurring failure in your tests, how do you find the traces to look for? I think, and everything we've seen so far has just been distributed tracing. And distributed tracing is valuable by itself, but for observability, there's more to it than that. There's the everything in between graphs and traces that get you to the right trace. So for instance, if in Honeycomb I grouped by the error message and the test name, I could detect the solid purple line, pretend I'm pointing at that to see the graph, the recurring failures versus the times when we just broke the tests and we needed to fix them. And then maybe you go back to that trace and you're like, oh, you know what? This always happens when this test is running in parallel with this other one. And maybe there's some conflict between the two, kind of thing.
Well, I think crucially as well, it provides a self-service capability. So streamlined teams that are using a platform like this, they can self-serve this stuff. They don't need to put in a Jira ticket request or go and ping an email or ServiceNow request into the platform. This is all self-service. They can look at this stuff themselves and do the diagnosis themselves. And that's massively empowering. That's really the kind of thing that we're trying to do. If you are working the platform, you need to make sure that pretty much whatever you're doing is moving toward self-service for the teams that are using your stuff.
Self-service, like assist in making decisions. Because
yeah,
those streamlined teams have to be in charge. they have to.
Have to be in charge, and they shouldn't need to send an email or open a ticket in order to kind of get an answer to something. There should be tools and stuff there that allows them to dive into the details and see for themselves the vast majority of the time.
Yeah. So internally, observability can give you an interface to help people fix their own use of the platform. Yeah. Finally, I had two little things. If you put in Honeycomb when you're doing a deploy, then all the teams can see that. So there's a sharing of important events. And there's also a sharing of activity history. So you can see what questions other people are asking. And this helps people learn their way around the data. It also increases communication between teams. And then you can go look at the same graphs and see what other people saw and share context.
And that's really cool, because that's a little bit like a kind of Stack Overflow, but for very specific technical questions around tracing and stuff. And it's massively valuable. Hugely valuable.
Cool. Yeah, and I mean, I really like observability as a way to increase your way of sensing, because as these streamlined teams in particular own the software, they get to make the software tell us what we need to know.
We start to use tools around observability like Honeycomb to augment our ability to sense what's actually happening in the systems that we're working with. Yeah. And that's not, it's not just the kind of software systems, it's our team systems as well. What we, like I said before, it's socio-technical now. We've got this awareness that it's this combination of people and technology that is the system. And so we need to, if we're starting with that perspective, the way in which we use some of these tools actually becomes much more, we use it in a way which is much more powerful. We're asking questions not just about the technology, but about the teams and our relationship.
There's some important news in the chat. This is a longhorn beetle, not a cricket.
Oh no, we got the name wrong.
Thank you, Blake.
Thank you, Blake. Longhorn beetle. Fine. So maybe they're not antenna, maybe they're horns instead. Anyway, but we thought we found a good photo here. Just imagine their antennas and not horns. That's the impression that we wanted to get. They are antenna. Oh, great. Fab. Thank you.
Good.
Thank you, Blake.
Right.
I wanted to. Yeah, go
ahead.
I just wanted to pose the question. The way in which we use teams and think about teams and things can have a big effect on the ability of the organization to sense its internal and external surroundings. And I'd like to ask this question. If you have something called an SRE team, does it actually help or hinder that organizational sensing? So SRE,
does it take people to take the streamlined teams farther from what's really happening in prod, or does it bring that information to them?
Exactly. Because what I've started to see in the industry, and I'm actually giving a talk on this next week, I'm actually starting to see teams go backwards organizations go backwards by about 15 years. What they're doing is they're having application development, and then application development kind of building the software, and then handing over to what they're calling an SRE team. And that sounds an awful lot like what we had about 10, 15 years ago, where we had development and operations. And we've just had a whole entire movement called DevOps, where we're trying to bring development and operations closer together. And it seems like lots of organizations are in the process of splitting this stuff apart, but just with different names. And so it's really, really kind of urgent that organizations get to grips with how they're going to use a team of reliability experts inside their organization. Because there's a real danger that it just becomes another silo. So SRE, site reliability engineering.
Is that like part number 3 here on this diagram?
Well, yeah. So this diagram here is from the Team Topologies book. And we talk about the way in which Google describes its use of SRE. So site reliability engineering. These days, if we were to come up with the term SRE, we wouldn't use the word site because that means website. Who has a website these days? I don't know. It's like an old style thing. We might call it system reliability engineering or something else, whatever. It's about reliability engineering at scale. And Google's starting point is always a team that builds and runs the service. In Team Topologies terminology, that would be a streamlined team. They call it something different, doesn't matter. They've got end-to-end responsibility for that service. They're on call for the service, and they're the only ones who are going to make it reliable. If that service gets more and more successful, more and more people use it, they might get some help as a kind of enabling team, the consulting help from some reliability experts. So that's
number
model
two in the slide, right? Yeah.
Exactly. But the streamlined team there is still responsible end to end for the runtime success of that bit of software. Only when the software gets so huge that you start to see 1 in a million problems occur every day, or something like that. When we start to see these strange behaviors, emergent behaviors, precisely because it's so large and complex, then at Google you might move to model 3, where you have some help at runtime from an SRE team, but that's actually relatively rare, and it needs a very careful balance. In lots of organizations, so I should say, eventually, if the service then becomes less interesting or has fewer users, it reverts back to number 4, which is the same as number 1. So basically, the streamlined team still has some responsibility. The challenge for lots of organizations is that they hear about this SRE thing. It sounds great. They put in an SRE team, but then they've got a kind of they've really misunderstood what's going on. And if you have an SRE team which is responsible for running applications in live, that's not shown in this diagram, by the way. That model is not a model that Google really uses. I mean, people think it's model 3, but they're misinterpreting it. You've got a separate group which is completely separate from the streamlined teams, and they just take some applications, deploy it into live, and run it. Then they are the ones who are closest to the action. They're the ones who are closest to the live system. They're the ones who are listening.
An anti-pattern would be if your SRE team is the only ones with access to Honeycomb.
Exactly.
Or the only ones running queries.
Exactly, that kind of thing. Or the only ones with access to production. Because then the streamlined team who's building the software doesn't have that sensing, is not able to listen to what's happening. So it's just it's really something to ask. If you do have something like an SRE team, is it actually helping your organization? Is it helping the teams to sense what's happening to the software? Or is it actually kind of cutting those teams off? Is it cutting off some teams from being able to understand what's happening in live environment? Yeah. And you can ask questions around the tooling, particularly access to tooling. Who's got the licenses to use a tool like Honeycomb?
Oh, yeah, and that's one reason Honeycomb does not do user-based licensing.
Yeah.
Or user-based pricing. We want you to give everyone access. All the developers, also often product owners use Honeycomb, like check how often features are used kind of thing.
It's incredibly important. I mean, that's where license model actually drives behavior in the bigger organizational system. So it's incredibly important that you've chosen that licensing model, because licensing model which drives per user or headcount licensing can end up in a real mess where you've just got a select group of people who have access to a particular kind of tool, and that's cutting off those kind of signals from other parts of the organization.
Stephen asks, what can an SRE do to improve sensing?
That's a nice question. So let's answer that one. If we're using model 2, like we're showing in the diagram here, where the SRE team is an enabling team or acting like a Team Topologies enabling team, then the SRE team can help the streamlined team to really understand what traces really mean and how to interpret charts and graphs inside a tool like Honeycomb.
And what to add to their traces.
And what to add to them to make it better.
So that they can find the forest, so that they can break it down by user device or customer ID or whatever, whatever's relevant to the business.
Yeah. But and also just kind of increase the awareness within that streamlined team of different kind of failure modes. For example, here's how this thing could fail. How are we going to detect that? Talk it through with them. How would you detect that this particular third-party API is kind of flip-flopping, up and down all the time? How do you detect that? Let's work through some examples that help you detect that's what's going on, and so on. And that is model 2 is really should be the starting point for most organizations, unless you're massive scale. No, model number 3, where you've got kind of a somewhat separate SRE team, is potentially leads to this kind of silo, basically. So stick with the model 2, where SRE team is like an enabling team until you really need something different.
Yeah, because if you want to make something reliable, you need to be the person making that thing, which is the stream-aligned team.
Exactly.
Not just taking it and somehow tacking on reliability.
Painting on some reliability paint, right?
Yeah. Well, we'll just restart it every 5 minutes. That's it.
Yeah.
Another person, Jamin, asks, we're talking about boundaries earlier, and they want to know, what about in smaller startups where teams aren't well defined, or people have multiple roles? Are there any insights for that?
It's a great question. So thanks, Jamin. I think actually in a very small organization, a lot of the challenges that we try to address in Team Topologies, and some of the challenges that you try to address in using a tool like an observability tool, you might not have all those challenges anyway, because actually if you've literally only got, say, 15 people, then you can get by with just having conversation between people. So you don't necessarily need to go to the same extent as if you've got 70 teams or 1,000 people.
Your traces are still going to help with those conversations.
They're still useful for sure, but
you don't have to get as formal.
You don't have to be as formal. And actually, if you're a startup, you might need a bit of fluidity. You might be better keeping your systems in a kind of a bigger block. And I hesitate to say monolith, but anyway, kind of a bigger, chunkier system, precisely because you don't know where the boundary should be yet. So just hesitate until you do that split. And
when you do that split, then your observability can help you to find a place for it, and can help you onboard new teams to show them what's going on.
Yeah.
I think, let's see, Ahmed has his hand up. Let me try this allow to talk thing. Hey, Ahmed, what's your question? Ask to unmute. I haven't tried this before. Ahmed, are you there? Okay, I guess not. Put your questions in the Q&A, and then they will hang out and be there when we can get to them.
There's a question from David a while back, saying that we wouldn't want to alter the boundaries too frequently, as this would impact team cohesiveness. So there's a couple of different things there. One, we can still keep the composition of the team basically the same, ideally, and not change the membership too much, but still kind of adjust the responsibility within the responsibility of that team. So we're taking on a little bit more of the API, or we're giving some away. Or
so don't adjust the team by adding or removing resources. Adjust the responsibility.
Exactly. Yep. That's a much more succinct way to put it. Thank you.
Yeah, and let's see. David Priest in the Q&A wants a summary of the definition of complicated subsystem team.
Complicated system team specifically is we try and avoid having a complicated subsystem. We only put one in if there is some particular aspect of writing software or building a system which requires really specialist knowledge, which would be difficult to cite inside a streamlined team. In fact, let's just go back, Jessica, to slide 10.
Oh, right. It's just close the slide. But since,
so
it is not showing me the numbers.
Not showing the numbers.
We wanted the team diagram, right?
Yeah, further up.
There it is.
That one. So this complicated subsystem here, typically it's where we've got some really awkward, really difficult calculations. It might be matrix maths. It might be video processing. It might be some transaction reconciliation stuff, this kind of thing, which is really involved, and where it would actually be really tricky to have that inside the streamlined team. And so we kind of pull that stuff out. There is a risk that starts to block flow. So we have to be really careful. It has to be managed like a proper product. It's not just a group of specialists sitting in the corner cranking out algorithms. It's managed as a proper product. But the reason we do it is to help encourage a flow of change in the streamlined teams, and to limit the cognitive load in those streamlined teams. That's the only justification from our perspective to create a complicated subsystem.
Right, because so much of team topologies is about recognizing that the limitation on a team is cognitive load, and that the team boundaries are knowledge boundaries. Who knows what, who understands it deeply enough to change it safely.
And there's a degree of capability that we can increase by going on training. But for example, I mean, I'm not the best programmer in the world by a long way, but if I'm working in a streamlined team, there's absolutely no way that I could easily and quickly get up to speed on writing some video processing codec stuff. It's just not going to happen. There's a whole lot of mathematics which I would have needed, years to acquire.
It would be enough of a challenge to get up to speed on interfacing with some video codecs.
Yes. Yeah. So it's that kind of dynamic which would then tell us, oh, might be a good case for complicated subsystems.
This is where an abstraction boundary is really useful. And we understand it well enough to create an abstraction boundary. Okay. Jacob has a question that I find really interesting. He's asking about how you sell streamlined teams to old traditional development teams who have ever operated a system. So the question is, if you have people, like as individuals who are not used to working this way, do you change the people, or do you change the people by swapping them for other people?
It's a great question. And I think part of the answer there, Jakob, is to give people the experience of what it's like to see their code running in the live environment. Give them tools like Honeycomb or some equivalent. Yeah. I mean, maybe
got to give them that visibility.
Maybe you think there's no equivalent, but anyway, so equivalent like this, because without having that observability, it's like flying blind. It's not something that's very pleasant, but actually having that visibility into logs and traces and metrics and so on means you get a feel for how the software is actually working. And it's kind of, I don't know, some people find it kind of exciting when they see this stuff working and they really get a feel for what's happening. So some people might be persuaded if they have exposure to and access to these kind of tools that actually help them to see how this software is running.
Because right now they don't have the powers that they need. They don't have the ability to see what their changes affect, and so production is scary.
Yep.
Yeah, and so like getting familiar with digging around in production and finding out what's happening, both at the monitoring level and the trace level, and I think observability is what gets you in between that, finding out what's important and narrowing it down. That is a start. I mean, not everybody's gonna want to change, but people respond to the situation, man. We are not who we are inviolably.
I think if we deploy, the way in which we use tools like Honeycomb and all kind of other tools, ticketing systems and code, the version control system, the way in which we use these tools, the kind of permissions that we give to different people, has a huge effect on people's ability to kind of empathize with users, to feel ownership over the systems. It's really important that we take a real degree of care about those kind of things. It's just licensing. Well, no, it's not just licensing. You're having a strong effect on how well people feel able to own the system and how invested they are in it. So these things end up being much more strongly linked than a lot of people expect.
Yeah, people are who they are in a situation, and we can change that. We have like 2 minutes left. Matthew, any final thoughts?
I think my final thoughts are that it feels like there's an awful lot more to think about when building modern software systems than before. The good thing is that the quality of tools now is just amazing compared to even just 10 years ago. Absolutely astounding. So let's make sure we take care to really understand the dynamics inside the organization, It's not just a static thing. It's not a machine. It's kind of an ecosystem. There are actors doing stuff, and our actions can affect other people. So let's think about the kind of more holistic effects of introducing different tools, of giving people different permissions to use things, and the relationships between different groups, different teams, whatever, in the organization. Let's see building software as, you know, an ongoing series of kind of relationships, not as a mechanistic, let's build this thing. I think that sets up organizations for success.
Yeah, building software is an ongoing work on relationships. The tools can give you clues, but you're going to have to talk to people.
Yep.
Yeah, and it's never done. But this webinar is done. Thank you, everyone, for coming. Thank you for your questions and your chat. Bethany, will you send everyone an email with the recording link when that's up?
Yep, just drop that in chat and we'll send out a recording today.
Okay, yeah.
And Jessica, I should say we've got 20% off at the Team Topologies Academy. So there's a link on this slide here, and we'll be tweeting some things out from our Team Topologies account very shortly. If you want to do some live on some online training, video training based on anything to do with Team Topologies, then that 20 off Honeycomb webinar will get you that 20% off.
Great, thank you so much. Yeah, and check out Honeycomb Dev Week. That was honeycomb.io/developer-week. I put that in the slide. And yeah, see you online.